The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's Online CEU Program, depending on their content. You can earn continuing education credits through ACI's Online CEU Program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our first presenter is Aamer Syed, and Aamer is the Senior Product Marketing Manager from Sika Corporation. And welcome, Aamer.
Thank you. Good afternoon, everybody. I will spend the next 20-25 minutes talking about prepackaged SCC repairs. To start the conversation, I do want to talk a little bit about SCC in general. What is SCC? It's really a solution to an old problem. We all know that. Being an engineer myself, I can relate to this picture very well. We can dream and we can think about the best possibilities, but when it comes to the practicality on job sites, the contractor has to make it happen. The contents of my presentation today are going to be talking about SCC in general, SCC, the difference between SCC and repair and new construction, and we'll briefly go over about 6-7 projects, a lot of pictures on SCC applications and repair. SCC in general, just to really whet our appetite for SCC this afternoon. SCC is a highly flowable concrete, non-segregating concrete that can spread into places, fill the formwork, and encapsulate the reinforcement without any mechanical consolidation. This is the definition by ACI 237. What is the need for SCC today? This slide looks like it is really geared towards new construction, but the same situations do arise when you're repairing a structure like this. So it's no different than new construction versus repair. The scope may be a little bit smaller, but the applications are very, very similar. Just to give you a little bit again, get our appetite going for SCC discussion today, I did include a quick video on SCC versus conventional concrete. It is not a repair application in general. It's basically the construction of double T's. And it can show you or get our minds thinking about the difference, the striking differences between conventionally placed concrete in a double T application versus conventional concrete. So this is the conventional about 9-inch slump concrete being placed in the double T application. You got about 5-6 guys trying to place this material. A lot of people sitting and waiting for the jobs, what to do next kind of application really. You definitely have the vibrator going, trying to help to place the concrete. It's a pretty decent fluid mix, but you can see there's a lot of difficulty in trying to push the material out where it needs to go. And when we get to the next part of this video, where you can see the striking difference between this concrete and the SCC. Typical application, you got a bull float, you have a guy trying to push the concrete, take some scrap off, and the bull float is going to basically help it screed it off and kind of give it a finish that they're looking for. Once again, a lot of touches, a lot of people trying to push the concrete, level the concrete, float the concrete, a lot of labor-intensive application, right? And when we go to the next piece of the video where it's going to show you the SCC, you can see the number of people involved in the construction or the fabrication of the same precast element. It's not a bad job to have every day, right? 8 hours a week, 8 hours a day. And now we go into the SCC application really. And you will see the striking difference once again between conventionally placed concrete and SCC. And the key to note here is, again, this is common for SCC, whether it's new construction or it's repair, that the concrete has to be very fluid, but at the same time, the stone that you're using in the mix has to stay suspended in the mix. You can have a fluid concrete, but if the stones start separating out, it is definitely not good. Once again, you see the number of people now involved in this application are very minimal. It's very, from a labor perspective, there's only 2 people really needing to do anything. One guy kind of got in the chute, and another guy kind of just supervising it. So once again, you can see very fluid mix, keeping a very sharp edge on the concrete, stone very much suspended, and once again, the same point being the SCC coming out of a bag in the repair application has got to be different, no different than what you're seeing right now. And this will basically just give you the amount of distance that the SCCs can travel from one point to the other. And I do have to watch my time, so I'll have to cut the video a little bit short, but I think we get the message here real quick. Let's talk a little bit about SCC repair and new construction. What are the different terminologies, if any, or the testing methods that we use in SCC while testing it in repair or in new construction? Really, the properties, as far as the properties go, the filling ability, the passing ability, and the segregation resistance, when it comes to precast or cast in place or in repairs, they are the same. As far as filling ability goes, you have to make sure that the material has the ability to flow into spaces with the formwork under self-weight. Passing ability, we have to make sure that the base material is able to pass through reinforcement, congested reinforcement. And the last thing is the segregation resistance. No matter how fluid the mix is, it has to make sure that it's segregation free or it's not going to separate out of you. These properties are similar when it comes to SCC, whether it's coming out of a bag or it's coming out of a precast facility. Again, the fluid properties of the SCC, once again, exactly the same, whether you're talking about new construction or ready mix, or SCC being construction, or basically SCC that is being coming out of a prepackaged bag. When it comes to flowability, passing ability, and segregation, these are the test methods that are used for SCC, conventional SCCs, and the same test methods are also used for developing SCC that are basically being sold in the marketplace for repair applications. We're all familiar with these tests. The flow cone method, basically 1611. The same test is used to measure the fluidity of an SCC in a bag. The J-ring test method, same test method is used to measure the fluidity and the passing ability of the SCC that is being produced in a bag. And of course, the L-box test, you can see, whether it's an SCC in a bag or it's conventional SCC being produced in a concrete precast factory, it's the same test. And as far as the mix design goes, it is no different again, whether it's an SCC being proportioned in a ready mix plant or whether it's SCC being proportioned to produce in a 65-pound prepackaged bag or 60-pound prepackaged bag, it is the same thing. You definitely have a higher concentration of sand in SCCs, and that is the same for both the type of SCCs that are out there. Now let's get into the SCC applications and repair. This is a project in Indiana. It's a bridge structure. The owner on this project is Illinois Tollway Authority. It's an approximately 40-year-old bridge. Extreme repairs from a size and volume perspective. This project, the SCC prepackaged material was actually pumped into place, and a lot of material was used on this project with a lot of success. Just to give you some idea, what must be a smart contractor who actually was testing the slump on site, making sure that what he's using and putting that in the forms is actually meeting the spec. And if you do all the precautions, you do get a good repair in the end. This is another project. Basically, it's called the Dry Fork Power Station in Wyoming. This is a brand new construction which the contractor did not make provisions to protect this anchor bolt sleeve holes, and water collected into it, and it froze and basically caused a lot of expansion and freeze-thaw and caused a lot of spalls in the end. Again, a lot of congested reinforcement. The need of the hour was to make sure that you get a bag material or something that can basically be filled in with success and get you a nice repair. The depth of the repair in this application ranged anywhere between 2 inches to 12 inches, and the total size of the repair in this application was about 300 cubic feet. Once again, a smart contractor, and this goes a long way. If a contractor is trained enough to make sure what he's putting in the forms, he's verifying the slump on that material. And this is the repair area, just to give you some idea what the repair looked like. It was a long beam, about 20 feet long, without any construction joints, about, like I said, anywhere between 2 inches to 12 inches deep, without a single crack. It's a perfect application for an SCC, and the contractor was basically pouring it through a chute. Another project, this project is a bridge project in Knoxville, Tennessee. The bridge was built in 1931. Some of these sections were actually demolished, and the bridge deck and the supports were replaced. They also added a traffic lane to it. There was a lot of, since the bridge was about 60, 70 years old, there was a lot, probably 80 years old, there was a lot of repairs that had to be done to the arches and the piers. The total scope of the project for repairs was about $24.7 million. And if you look at the activity, the top deck has been taken off, and they're doing a lot of repairs on this project. And we can probably look at the, zoom in on the repaired section right here. This has all been done with a prepackaged SCC. Now, if you think about this, if you compare this to a conventional new construction application, an SCC would be a perfect product for this. So when you're going to go out and fix these applications in concrete, an SCC in a bag also helps you with the same kind of technology. This is another project called Air Force Academy in Colorado Springs. It's a U.S. Army Corps of Engineers project, actually. They had 2 large bridge structures, supports that were in need of repair. Some repair areas were, again, as deep as 12 inches. Difficult access to repair areas, need a lift for material and personnel, so a ready-mix option was basically considered, but it was not practical to perform in the repair areas, so they elected to go with, again, the repair material, which was an SCC, getting all the benefits and the qualities of an SCC, but basically in a bag situation. Some idea of the access area limitations. If you see the guide, this area is actually the section that was repaired. I think I have a close-up picture that probably gives you a much better idea. And the guy is basically mixing it up, and they will be in the next picture. You can see the material is going to be poured right here. So a lot of concrete was being repaired, you can see, through an SCC pre-bag mix very successfully in restoring these Air Force Academy bridges at the U.S. Army Corps of Engineers. Another interesting project, this is basically Romano Vineyard Way Bridge. This is up where in New England, and I remember this project very well because I got a call from the salesman telling me that there is some new construction defect that he has to talk to an engineer about getting it fixed. They have some repairs to be done, and I asked him specifically, what do you think the thicknesses are? The answer given to me was about 6 to 7 inches. But as the salesman went onto the job site, he found more details about it. That the concrete in the structure was poured at 105 degrees Fahrenheit, and the concrete, of course, set up too quickly. And this is what it looked like. This is a brand new structure. So the story doesn't end here. It gets worse, because once you start shipping it out, that's how it looked. So basically, all through the section of the thickness of the repair, this had to be repaired. And really, I'm trying to repair this section with a conventional 7, 8, 9-inch slump. It is a challenge. So the prepackaged SCC, again, helping out quite a bit in trying to get these repairs done. And you can take a look at this. The chute has been created, and you're basically just pouring and placing the SCC right out of the buckets into the formwork. And this is the repair section, one of the repair sections. Of course, this is the chute that will be chopped off once it's all said and done. But once again, the SCC making the project a lot more easier in trying to accomplish the objectives of the repair. Another project called Jewelers X-Lane in San Diego, California. It's a cast-in-place concrete from very old structure, about 100 years old. Significant cracking, corrosion, and spalling caused by water intrusion for many years. Wall columns and stairs and showrooms were all affected. This is the extent of the corrosion here, that you basically see this much of concrete gone. About 33% of the concrete in columns were gone. So, of course, you needed a mix that could flow well without segregation. And again, once again, the SCC in a bag sort of solution came to the rescue, and the job was performed with that. This is the repaired section after the formwork has been removed. Not the best quality picture, but that's what I had. The Hobart Bridge is one of the projects where an SCC material was used. This is, again, the toll road on I-90. This was repaired in 2008. A lot of material was used, mainly substructure, piers, and caps that were repaired. You can see the extent of damage in these structures. You can probably do this with conventional 8-9-inch concrete, some concrete, but getting it done with an SCC makes it a lot easier for the contractor, and you actually end up getting a much more durable product. This is basically the section that's being formed up, and you get the lift, and the guys are basically just pouring the material right from the lift. This is how the structure looked once it's all said and done. One other project which was very interesting, it's basically multiple balconies in a New York City high-rise, major spalling on the top and the underside of the structure. Again, the prepackaged SCC was used on to repair the underside of the balcony. This is how the underside of the balcony looked after the surface prep was done. Pretty bad shape. And this is how it looked on the top when the surface prep was done. So really not a whole lot of section left in the middle. But an interesting way was you see these holes there? These are basically the holes through which the concrete was formed were poured, and SCC was poured, and since the bottom was formed, it filled up the bottom and also the top section. And in the end, this is how the repair project looked. So pretty nice repair application again. If you try to do this again with a very conventional 8-inch, 9-inch slump concrete, it would have been a challenge. But the SCC in a bag allows for these small repair jobs to be done with the same kind of success that you have in new construction. And coming back to my last couple of points on the SCC in a bag, it is not easy to formulate, first of all, an SCC in a bag, and the second part, it is not easy to maintain control on the quality of SCC in a bag. It is a very challenging task for production operations people to maintain the quality of this SCC in a bag. For the reasons being, once again, if people are very familiar with the kind of admixtures used to produce an SCC, the percentage of active ingredients that you use in making an SCC is very small. You're talking in single-digit percentage points in a whole concrete mix. And if you're not really watching the addition rates of those strong, potent admixtures that are used, whether it's a polycarboxylate or whether it's a different kind of chemistry, but it's a very small amount going into a huge batch that you're basically trying to make an SCC, the margin of error there is zero. If you don't get that right, you will more than likely make the batch not as effective. Okay, then of course you have this cement material coming in all year long in the factories trying to make an SCC, and cement varies. We all know that from season to season, from loads to loads, they vary. So a strong and a very tight quality control has to be maintained to make sure that the SC that is being shipped out of this batch in May will be the same that you probably put out in June and July. The bag weights, that's a huge issue. You're trying to basically maintain a very small water powder ratio, and if your bag weights are not accurate, that can lead to a lot of variations in the field. If your 65-pound bags are being pulled at 60 pounds or 70 pounds, you can either get a lot of segregation or you will not get an SCC. So again, the quality control in producing an SCC, the onus on the manufacturer just multiplies by many factors. That it has to be watched very carefully, and it has to be screened very frequently to make sure that the stuff that is get out there in the marketplace is as good as it is expected to be. The variation in aggregate is of course a huge concern. If you start getting a lot of variability in aggregates, it's going to affect the flow as well. So really, if you do not control all these factors very tight in a production environment that is producing prepackaged SCC in a bag, the success rate of the SCC in a bag is going to be very minimal. I can tell you, based on experiences, that the level of quality control that has to be put in for producing SCC in a bag is extremely high, and it has to be maintained at a very high level on a constant basis. Conclusion really on my presentation, that the prepackaged SCC technology is being used successfully in new construction for about, 20, 30 years in the U.S. now. But as far as when it comes to repairs coming out of a bag, I think it's been about 5-6 years where different manufacturers have come out with bag materials, and they are really making a huge contribution to the repair industry by doing that. They're definitely solving a lot of critical repair problems in the industry, which were a lot more difficult to deal with if those options were not available. That is prepackaged SCC. Prepackaged SCC has some very specific production requirements, and these bag goods, when you're placing SCC in a bag good, it should be produced to a very high quality standard. With that said, I'll take questions, if any. Yes, sir.
Are there any questions for him? Yes.
For your vertical repairs, you have to construct formwork.
Yeah.
For vertical repairs, you have to construct formwork.
Yes.
Overhead repairs,
absolutely.
shotcrete considered as a repair material?
On the Air Force project that I talked about, shotcrete was considered, but the logistics of the shotcrete application and trying to get the rig up and the distance, I think that was the decision factor where they elected to go with.
I would think shotcrete maybe a cost advantage to shotcrete.
It's the decision that was made, keeping the options that were available. I can tell you on that particular project, shotcrete was considered, but it was elected to go with an SCC in the back. Yes, sir.
I'd like to know if the strength of the new concrete with respect to the old concrete, is that an issue? Should they be similar? Or?
Well, the SCC that are typically out there in the marketplace are really formulated towards 5,000 or 6,000 psi, which is pretty much in line with what the structure is. You might be a little bit higher than conventional concrete, but we have not seen any issues as far as compatibility-wise, if that is what the question is. Yes, sir.
Does it relate to the non-shrinking grab?
Does it relate to the non-shrinking grab? That's the question. As far as I cannot speak for every formulation out there, the few that I know, as far as I can tell, most of them do not have expansive cement in it or expansive agents in it. They're just formulated to meet a very low shrinkage requirement. That is about 500 microstrands as per the 596 or C157 modified test method. So essentially what you're doing is you're not trying to control shrinkage by causing the SCC to expand or using expansive cement. You're just trying to do it basically with a very low water powder ratio with SCC. Yes, sir.
Do you need to have or apply a bonding agent to the old concrete before you use SCC then?
The question was, do you need to apply a bonding agent to a repair where you're using an SCC? From my experience, I can tell you, SCC being such a fluid mix, I do not see any value of using a bonding agent for a repair application. If there are bonding agents that are out there that basically solve dual purposes of reinforcement, protection, and bonding agents, you can use that. It's not going to hurt it. But as far as just looking to get the bond values higher, I don't think so you get any added value of that, sir.
The last question. Yes.
I actually went over this at the beginning of your talk. What are your typical slump flow values for the materials that you're talking about? That's one question. The second question is, what sizes of course aggregates do you typically use in this, and how does that compare to conventional SCC or traditionally?
So two questions really. The first question was, I guess the second question was, what size aggregate are typically used in the formulation of this prepackaged goods, which are SCC goods? The answer, there is about 3/8 inch size of aggregate. That's about the maximum people like to go with. And the first question was, as far as flow goes, the flow requirement is no different than what an SCC would be. The lower end of the spec is about 24 inches. The high end of the spec is about 30 inches.
Depends on the application.
Absolutely.
Depends on. Thank you so much,
Thank you
Aamer.
very much.
Yeah, Aamer will be here, and then you can ask him questions. Yeah.